We're given a joint probability table of j and k for values of k minus 1 to 1 and j minus 2 to minus 1. We're then asked for the MGF of j and k, and that is the moment generating function, if you did not remember. Then we're asked for the PMF of m, which is the sum of these two variables, and then the expected value of m to the fourth. So the first thing you need to do is, of course, you need to get the marginal probabilities. So I'll just quickly write these down here. Maybe I'll draw an extra line here. And of course, I did not leave enough space to kind of write here on the right, but that's okay. Oh, and there's a big ant on the board. Well, hopefully that ant leaves. But in the meantime, we will try to solve for the marginal generating function for j. So now we start with the PDF of j, and that should be kind of just given here, right? So it's 0.6 for j equals minus 2, and 0.4 for j equals minus 1, 0 otherwise. So kind of from this PDF, right, what is the marginal generating function? Well, it is kind of the expected value of e to the sx. So we write the final function as phi subscript j in terms of s, right, because kind of like the Laplace transform. So it's just 0.6 e to the minus 2s plus 0.4 e to the minus s. And then we can kind of do a similar thing for k. So I'll just write the answers here because it's pretty straightforward. So minus 0.7 to the minus s, and then plus 0.2 times 1, so because e to the 0th is 1, and then we add 0.1 e to the s. So now let's find our probability PMF of m. So this is the sum, right? There are several m's that we can have. Right here it's m equals minus 3. These two probabilities represents the sum of m equals minus 2. This one here, oh my god, it's coming up the chair. The ant is coming up the chair. That's okay. And then this one, here's m equals 0. And so we can write the PMF here. And I guess I'll write it here. Let's move the board up a little bit. Okay, nice. And it is 0.42 for m equals 3, 0.4 for m equals minus 3, minus 2, it's minus there, and 0.14 for m equals minus 1, and 0.04 for m equals 0. 0 otherwise. And now we can try to get the expected value of m to the fourth. And that, right, is just, we can solve this directly instead of using the moment technique, because it's actually a lot easier. So this sum just turns out to be 0.42 times minus 3 to the fourth plus 0.4 times minus 2 to the fourth, and so on and so forth. Right, 0 to the fourth, and the answer is hold on, I can't read my own handwriting. 40.434. Do we have that in the camera? Okay, 40.434.